So hello guys, in our SS1 lessons on carbon, we discussed the concept of allotropy to a great extent. We mentioned then that diamond and graphite are the major crystalline allotropes of carbon. Now oxygen also exhibits allotropy, and some of its allotropic forms include monoatomic oxygen radical, diatomic oxygen gas, triatomic oxygen, and even a metallic zeta phase form. We have discussed the oxygen atom and the diatomic gas. The zeta phase form is almost impossible to spot because it only exists at extremely high pressures of about 1 million atmospheres. So we'll only look at ozone in this lesson. Ozone is the triatomic form of oxygen, meaning that it has a chemical formula of O3. It was first discovered in the late 18th century by Dutch chemist Martin van Marum. He sparked electricity over water and noticed an unusual odor. However, he did not realize that he had just discovered a new substance. In fact, he claimed then that the odor came from the electrical reactions. In 1839, German scientist Friedrich Schombein noticed this same smell. He noticed that the smell was similar to that smell observed after a bolt of lightning. Now this led him to successfully prepare the gas and call it ozone. However, it was until Jacques-Louis Soré in 1866 determined the formula of the compound to be O3 that we learned that ozone is an allotrope of oxygen. As implied by our lesson thus far, ozone often occurs naturally after lightning and electrical discharges. However, it is so unstable that it immediately converts back to oxygen gas. Basically, what happens during the production of ozone is that the electric spark or bolt of lightning energizes oxygen atoms in the atmosphere, changing them to ozone. This idea led to the invention of a device called an ozonizer. It is basically a device that works by passing an electric current through a stream of oxygen gas. The electrical energy breaks down some oxygen molecules, which then attach to other oxygen molecules to form ozone. Ozone has a pale blue color and smells like a solution of chlorine bleach. It is extremely poisonous even in small concentrations, but dissolves in non-polar solvents like chloroform and turpentine to form a blue solution. Ozone reacts in a similar way as oxygen gas. The only seeming difference is that it is a stronger oxidizing agent, and this is due to the fact that it is ever ready to decompose and release oxygen gas. Due to this same reason, it serves as a very good bleaching agent. In fact, its use cannot be exhausted. Ozone is used for making disinfectants and sanitizers. It is used for making air purifiers kept in homes and public places to deodorize air. It also finds use in water and sewage treatment facilities to eradicate waterborne parasites. Also, due to its oxidative property, it is used for manufacturing important chemical compounds like lead-2 tetraoxosulfate 6, which is used for making car batteries. But unquestionably, its most important use is in the stratosphere, where it forms a layer that prevents the harsh ultraviolet rays emanating from the sun from getting to the earth. But do not worry, we will explain this in depth soon. For now, the key points to note include: ozone is an allotrope of oxygen and was officially discovered by Friedrich Schombein. It is prepared using an ozonizer by passing an electric current through oxygen gas. It is pale blue in color and very toxic. It is used during many purification and manufacturing processes. Don't go too far, I'm waiting for you in the next lesson.